The comprehensive information presented in this broadcast is strictly intended for educational and informational purposes only and does not constitute professional automotive engineering, legal, financial, or medical advice. Purchasing a wheelchair-accessible vehicle, particularly a sport utility vehicle, involves highly complex structural modifications, advanced engineering alterations, and substantial, often irreversible, financial commitments. Because every individual's mobility equipment features highly specific dimensions, unique weight distributions, battery placements, and specialized tie-down requirements, the generalizations discussed in this program may not apply to your specific physical or mechanical situation. Viewers are strongly advised to conduct their own exhaustive due diligence before initiating any vehicle search. Prior to making any vehicle purchase, placing a non-refundable deposit, or signing binding contracts for custom mobility conversions, you must consult with a certified driver rehabilitation specialist, a licensed occupational therapist, and a credentialed mobility equipment dealer who actively represents the National Mobility Equipment Dealers Association and strictly adheres to their quality assurance program. Furthermore, the financial implications of vehicle conversions involve complex tax considerations, potential eligibility for state or federal grants, specialized insurance underwriting, and long-term financing hurdles. We do not offer financial or tax advice of any kind. Historical trends indicate that extensive vehicle modifications can drastically alter a vehicle's factory payload capacity, aerodynamic drag, crash test safety ratings, and original manufacturer warranties. Always verify the rigorous safety compliance of any modified vehicle through the National Highway Traffic Safety Administration guidelines and federal motor vehicle safety standards. Your personal safety, physical comfort, and financial security are paramount. Please utilize this material solely as a foundational educational tool to empower your independent research and consultation with certified professionals. Imagine wiring $95,000 to an out-of-state dealership for a beautifully equipped, brand new sport utility vehicle and its highly anticipated, top-of-the-line wheelchair conversion. You wait 6 months for the complex fabrication to be completed. You finally take delivery, only to realize a devastating, irreversible truth. The interior cabin height is exactly 1 inch too short for you to sit upright in your complex rehabilitative power chair without your head constantly striking the interior roof console. Or perhaps you discover that the deployment angle of the automated ramp is too steep for your specific chair's motor to climb safely in wet weather. This is not a hypothetical scare tactic or an exaggerated scenario. Based on extensive case studies, verified consumer reports, and historical trends within the disability and mobility community, catastrophic purchasing errors precisely like this happen every single month across the United States. Families and independent disabled drivers frequently lose tens of thousands of dollars in instant, unrecoverable depreciation and non-refundable custom conversion costs simply because they relied on the aesthetic appeal of an SUV rather than verifying its deep structural compatibility. For decades, the global automotive industry has operated on a controversial, incredibly frustrating, and fundamentally flawed assumption that wheelchair users only want or only deserve to drive minivans. While minivans undeniably offer excellent interior volume, practical low floors, and sliding doors, the reality is that the broader American consumer landscape is overwhelmingly dominated by the sport utility vehicle. Drivers want aggressive ground clearance, they want robust all-wheel drive capabilities for navigating harsh winter climates, they want substantial towing capacity for weekend recreation, and quite frankly, they want the rugged, modern styling that a traditional SUV provides. Nobody wants to feel culturally sidelined into driving a vehicle they do not aesthetically enjoy. Yet, converting an SUV for true wheelchair accessibility is a staggering engineering nightmare. Unlike a minivan, which natively sits relatively low to the ground and features a wide, flat interior floor pan, an SUV is explicitly built to ride high. To make an SUV accessible, specialized engineers essentially have to cut the vehicle entirely in half, severing its core structural rigidity. They must then drop the floor by 10 to 14 inches, reroute the complex exhaust systems, relocate high-capacity fuel tanks, and completely re-engineer the entire rear suspension geometry, often replacing independent rear suspensions with solid axles just to make room for a ramp pan. If this highly invasive process is executed on the wrong factory chassis, the vehicle immediately becomes structurally compromised, prone to severe, cascading mechanical failures, and incredibly dangerous on the highway. The harsh reality of the current U.S. automotive market is that out of the dozens upon dozens of attractive SUV models available on dealership lots today, Roughly 95% of them are completely incompatible with safe, reliable, long-term mobility modifications. If you choose the wrong base vehicle, you are looking at potential outcomes that include ruptured fuel lines, shattered aftermarket drive shafts, rapid tire wear due to misaligned geometry, and a heavy vehicle that violently bottoms out on every minor speed bump in your neighborhood. But what if I told you there are a select few vehicles that beautifully defy these restrictive engineering limitations? What if you could bypass the minivan stigma entirely and step into a highly capable, visually stunning SUV without sacrificing a single millimeter of highway safety, interior maneuverability, or long-term reliability? In this exhaustive deep dive masterclass, we are going to meticulously decode the top 3 wheelchair-accessible SUVs currently available in the US market today. We are not just giving you a superficial sponsored top 3 list. We are going to systematically tear down the specialized engineering behind each specific conversion company. We will analytically compare the distinct advantages of side entry versus rear entry configurations for SUV platforms, analyzing the exact ramp slope angles, the width of the door openings, and breaking down the critical gross vehicle weight ratings and payload capacities that standard automotive dealerships frequently misunderstand or intentionally hide from you. When you add a 400-pound power wheelchair, a human occupant, and several hundred pounds of steel conversion equipment to an SUV, you fundamentally alter its center of gravity and braking distance. We will examine the historical trends of depreciation for these 3 specific models, clearly showing you which customized chassis holds its immense value on the secondary mobility market, and which one historically plummets in worth the second you sign the title. For the American consumer currently navigating the incredibly stressful, confusing, and financially daunting world of specialized mobility vehicles, this broadcast is engineered to be your ultimate equalizer. Whether you are a disabled veteran looking to optimally utilize your Department of Veterans Affairs automotive grant, a parent trying to safely and comfortably transport a growing teenager in a heavy pediatric power chair, or an independent driver who simply refuses to compromise on personal style and automotive utility, the rich data and insights provided here will arm you with the factual leverage you need to make a bulletproof purchasing decision. We will deeply explore the nuanced, often ignored differences in interior turning radiuses, allowing you to visually understand exactly how much space you will actually have to maneuver a complex mid-wheel drive power chair into the driver's position or the front passenger position. We will also reveal a closely guarded mobility industry secret regarding a massively popular luxury SUV that many consumers mistakenly attempt to have modified. A disastrous decision that case studies show frequently results in catastrophic electrical grid failures, permanently voided factory powertrain warranties, and endless dealership repair loops. You absolutely need to know exactly which vehicle architectures have the robust structural integrity to support a heavily dropped floor and a motorized ramp system without ever compromising the strict factory crash safety ratings. By the end of this comprehensive step-by-step analysis, you will possess a level of technical, mechanical, and financial understanding that rivals most seasoned mobility sales professionals. You will know precisely what highly technical questions to ask, what specific dimensional specifications to demand in writing, and what hidden engineering red flags to vigorously look for when physically inspecting an accessible sport utility vehicle. Do not make another move in your vehicle search, do not visit another dealership, and certainly do not sign any financing paperwork until you have completely absorbed the critical data in this breakdown. The choice you make today will irrevocably dictate your daily freedom, your physical safety, and your long-term financial stability for years to come. Let us begin unraveling the engineering marvels and the critical hidden flaws of the top 3 accessible SUVs on the market right now. To truly understand what separates a highly functional mobility vehicle from a catastrophic financial mistake, we must first deeply examine the anatomical structure of our number 3 choice, the specially modified Chevrolet Traverse. The current 2026 mobility landscape has shifted dramatically away from the traditional minivan, and the Chevrolet Traverse conversion fundamentally alters the genetic makeup of a standard sport utility vehicle to meet this demand. To achieve true accessibility, mobility engineers must take the factory chassis and execute a highly precise, laser-guided unibody frame cut. They completely sever and remove the entire factory floor from the front engine firewall all the way back to the rear axle. This is not a superficial bolt-on adjustment. It is a profound, highly invasive reconstruction of the vehicle's core structural integrity that requires immense reinforcement to maintain highway safety standards. To comprehend why this massive structural intervention is strictly necessary, we must analyze the factory door mechanics. Standard sport utility vehicles possess hinged doors that swing outward. When fully open, a traditional hinged door physically blocks the deployment path of a wheelchair ramp and forces the disabled user to navigate around a dangerous, rigid steel barrier just to enter the cabin. To solve this engineering bottleneck, mobility firms completely remove the factory hinged passenger door. They meticulously reverse-engineer the entire right-side exterior paneling to install a custom fiberglass and steel sliding door system that operates seamlessly with the original factory remote key fob. This custom sliding door completely redefines the vehicle entry point, expanding the lateral opening to a massive 54.5 inches of vertical clearance. This specific measurement is an absolute necessity for taller individuals sitting elevated in complex rehabilitative power chairs who would otherwise suffer severe spinal compression or head trauma trying to clear a lower door frame. Let us look at a highly detailed case study to illustrate the severe gravity of these specific dimensions. Imagine a retired engineering professional named David from Texas in the current year 2026. David relies on a heavily customized mid-wheel drive power chair, equipped with a complex tilt and recline seating system. He attempted to save tens of thousands of dollars by purchasing a lightly modified, older sport utility vehicle from an uncertified neighborhood mechanic who utilized a standard hinged door and a steep, non-compliant portable ramp. The mechanic retained the factory suspension and failed to lower the floor pan adequately. Within 3 months of daily driving, the added 800 pounds of the steel ramp, the complex chair, and David himself caused the rear factory coil springs to completely collapse under the continuous dynamic load. Furthermore, David constantly struck his head on the rigid door frame because the vertical clearance was only 50 inches. The compromised vehicle eventually bottomed out violently on a standard driveway transition, completely severing the hydraulic brake lines. David experienced potential outcomes that could have easily resulted in a fatal, high-speed highway collision. Historical trends within the mobility industry consistently prove that bypassing certified structural modifications and ignoring strict vertical clearance requirements leads directly to catastrophic mechanical failure and severe personal injury. Returning to the rigorous engineering of the modified Traverse, the newly installed drop floor is a 14-inch deep, heavy-duty steel pan coated in highly specialized, sound-deadening aerospace-grade materials. This thick coating is absolutely critical to mitigate the extreme road noise and exhaust resonance that typically plagues deeply converted, hollowed-out vehicles. When you press the deployment button on your key fob, a complex, synchronized mechanical sequence initiates. First, the custom sliding door glides open smoothly. Second, the heavy-duty kneeling system activates. This is not a simple, unreliable air shock system that leaks in cold weather. It is a heavy-duty electronic linear actuator system connected directly to the rear passenger side independent suspension arms. It mechanically forces the suspension to compress, pulling the right rear corner of the heavy vehicle down toward the pavement. This kneeling action drops the ramp deployment height by a critical 3 to 4 inches. Why is this highly specific measurement so critical to your safety? Because it dramatically reduces the slope of the deploying ramp from an unsafe, impossibly steep 15 degrees down to a fully compliant, easily navigable 9 degrees, ensuring your chair motors do not burn out during the ascent. We must also dissect the engineering of the ramp itself. The Traverse features an advanced in-floor ramp design, constructed from a rigid honeycomb aluminum matrix that supports up to 1,000 pounds of continuous dynamic load capacity. Unlike a traditional fold-out ramp that sits upright inside the passenger cabin, physically blocking the passenger window, creating dangerous blind spots for the driver, and rattling constantly over every minor pothole, the in-floor ramp stows completely out of sight beneath the modified steel floor pan. This means when ambulatory friends or family members enter the vehicle, they are not tripping over a massive, obtrusive piece of metal. The interior environment retains the premium, sophisticated aesthetic of a standard modern luxury sport utility vehicle. However, you must meticulously analyze the interior maneuverability, because this spatial geometry is exactly where many eager buyers make their absolute most expensive mistake. The modified Traverse offers a 60-inch interior floor length and a staggering 61 inches of interior height at the dead center of the cabin. This vast footprint allows the vast majority of power chair users to roll up the aluminum ramp, enter the vehicle, rotate their heavy chair a full 360 degrees, and dock securely into either the driver position or the front right passenger position. The front factory seats are mounted on specialized wheeled transport bases. You simply pull a high-tensile steel release lever, unlock the heavy base from the floor track, and roll the entire seat out of the vehicle and down the ramp to leave it in your garage. Your power chair then rolls forward and locks into a heavy-duty electronic locking mechanism mounted directly to the reinforced floor pan, allowing you to drive independently. You might be analyzing these impressive specifications and thinking this sounds like the absolute perfect solution for your mobility independence. Historical trends clearly show the converted Traverse retains incredibly strong resale value on the secondary market due to its high consumer demand, spacious interior, and robust all-wheel drive capabilities. However, you must carefully calculate the gross vehicle weight rating. The factory Traverse has a strict, federally mandated payload limit. Once the engineers add the massive weight of the reinforced drop steel floor, the heavy sliding door motor assembly, the thick in-floor ramp housing, and the heavy kneeling actuators, you have instantly consumed approximately 500 pounds of that strictly limited available payload capacity. If you have a family of 4, plus their heavy luggage, plus a 400-pound mobility device, you are dangerously close to exceeding the legal and safe weight limits of the factory braking system. You must mathematically calculate the combined weight of your specific equipment and your typical passengers before finalizing this massive financial acquisition. Furthermore, there is a severely overlooked, incredibly frustrating vulnerability with side entry sport utility vehicles like the Traverse. Imagine it is pouring freezing rain, and you pull into a standard commercial grocery store parking lot. You find a designated accessible parking space, but the striped access aisle is incredibly narrow, or even worse, a poorly parked adjacent vehicle has crossed over the painted line. A side entry system requires an absolute minimum of 8 feet of clear lateral space to deploy the ramp fully and allow the wheelchair to safely maneuver off the ramp surface without striking the neighboring car door. If someone parks too close to your passenger side while you are inside navigating the store, you are physically trapped outside of your own $90,000 vehicle until that other oblivious driver eventually returns. You are entirely at the mercy of the surrounding architectural environment and the spatial awareness of completely stranger drivers. This spatial vulnerability forces countless disabled drivers into deeply stressful, highly vulnerable situations, waiting hours in harsh weather conditions simply because their expensive side entry ramp physically cannot deploy. While the Traverse offers unparalleled interior space and premium exterior aesthetics, this external deployment limitation is a massive, uncontrollable variable you must heavily weigh against your daily commuting routine. But what if there was an entirely different architectural approach to this infuriating engineering problem? What if you could permanently eliminate the constant fear of being blocked in a parking space forever, while still driving a highly aggressive, deeply capable sport utility vehicle? What if the optimal solution involved completely ignoring the side of the vehicle and engineering a radical, highly controversial transformation of the rear cargo sector? The vehicle occupying our number 2 spot does exactly that, but it hides a devastating interior space compromise that mobility dealerships absolutely do not want you to discover until well after your return period legally expires. Enter the massively popular, culturally dominant, and highly requested rear-entry Kia Telluride, which confidently occupies the number 2 position on our exhaustive masterclass list. To genuinely comprehend why this specific vehicle configuration solves the agonizing parking lot trap we previously discussed, you must completely erase your understanding of the side entry engineering process. The rear entry modification is a fundamentally different architectural philosophy. Instead of slicing the entire vehicle in half and dropping the entire floor pan from the firewall backward, mobility engineers perform a highly localized, deeply surgical structural intervention exclusively down the center of the vehicle. They meticulously cut through the rear cargo deck, completely excising the factory third-row seating mounts, the hidden storage compartments, the spare tire housing, and a significant portion of the vital rear bumper crossmember. In place of this factory floor, they install a massive, elongated, heavy-duty stainless steel tub that runs continuously from the rear hatch door all the way forward to the back of the first-row driver and passenger seats. This specialized steel tub features a gentle downward slope, terminating at the rear bumper line where a bifold, aerospace-grade aluminum ramp is securely mounted. The immediate, world-changing advantage of this rear-entry configuration is spatial independence. Imagine if you are living in a highly congested urban environment in the year 2026, navigating the impossibly tight streets of a major metropolitan area. You rely on parallel parking daily. A side entry vehicle is entirely useless in a parallel parking scenario because deploying a side ramp directly into live traffic is a potential outcome that inevitably leads to catastrophic vehicle damage or severe personal injury, and deploying it onto a high city sidewalk is often physically blocked by fire hydrants, streetlights, or planters. With the rear entry Telluride, you simply parallel park, walk to the back of the vehicle, pop the power liftgate, and manually unfold the spring-assisted ramp directly into the empty space behind your SUV. You are completely immune to the narrow striped aisles of grocery store parking lots. You will never again be trapped outside of your vehicle in the freezing rain, because an oblivious driver parked 6 inches from your passenger door. The rear entry architecture guarantees your external access is always fully within your own control, provided you have roughly 6 feet of clearance directly behind your rear bumper. Furthermore, the mechanical simplicity of the rear entry Telluride is a massive long-term financial asset. Side entry vehicles rely on a highly complex grid of electronic linear actuators, sensitive optical limit switches, heavy kneeling suspension motors, and computerized sliding door tracks. When one microscopic sensor fails, the entire side entry system paralyzes, locking you inside or outside the vehicle. Historical trends in the mobility sector overwhelmingly demonstrate that rear entry vehicles spend drastically less time in the dealership repair bay, because the vast majority of them utilize a brilliantly simple, manual bifold ramp. This ramp is perfectly counterbalanced by heavy-duty, gas-charged hydraulic struts. It requires literally less than 5 pounds of physical lifting force to deploy or stow. There are no delicate circuit boards to short out in a severe rainstorm, no kneeling chains to snap, and no sophisticated door motors to burn out. You get the rugged, aggressive aesthetic of the factory Kia Telluride with a mathematically superior reliability record. However, we must now confront the devastating interior space compromise that mobility sales representatives consistently downplay during the emotional excitement of a showroom test drive. The specialized steel tub channel strictly terminates immediately behind the front factory seats. This rigid structural boundary dictates that the wheelchair user is permanently relegated to being a passenger in the rear cargo sector of the vehicle. You cannot drive this vehicle from your wheelchair. You cannot even ride in the front passenger position. You are physically isolated in the back, flanked by the factory second-row bucket seats. Let us examine a highly detailed case study to illustrate the profound psychological and physical impact of this engineering limitation. Consider a dedicated father named Marcus who, in the year 2026, purchased a fully converted rear-entry Telluride for his teenage daughter, Sarah, who utilizes a complex pediatric power chair. Marcus spent over $80,000 specifically because he wanted the rugged safety and high-end aesthetic of the Telluride, rather than a traditional minivan. On their very first extensive interstate road trip, the grim reality of the rear-entry configuration manifested. Because Sarah was positioned deep in the rear tub, her physical line of sight was entirely obstructed by the massive front center console and the high headrests of the front seats. She could not comfortably see the windshield, leading to severe motion sickness. Furthermore, the ambient road noise amplified dramatically. The stainless steel tub essentially acted as a giant acoustic megaphone, capturing the harsh resonance of the tires on the asphalt and echoing it directly into the rear cabin. Marcus and his wife sitting in the front row could not easily hold a conversation with Sarah without shouting over their shoulders. Sarah felt entirely disconnected from the family dynamic, relegated to the status of cargo, rather than an active participant in the journey. The physical isolation inherent in rear-entry sport utility vehicles is a severe, non-negotiable factor that buyers completely overlook until it is far too late to reverse the financial transaction. Beyond the psychological isolation, you must aggressively scrutinize the altered physics and structural safety of the modified rear chassis. When mobility engineers sever the factory rear bumper to create the ramp opening, they completely destroy the original Federal Motor Vehicle Safety Standards rear crush zone. The factory bumper is meticulously designed by Kia to absorb and dissipate the kinetic energy of a high-speed rear-end collision, directing that violent force away from the passenger cabin. In a poorly executed mobility conversion, the rear bumper is simply cut in half and capped off, leaving the wheelchair user dangerously exposed. If a distracted driver rear-ends a cheaply converted SUV, the kinetic energy drives the folded aluminum ramp directly forward into the occupant. You must demand to see the official independent crash test data from the specific conversion company. You must verify that they have engineered and installed a heavy-duty, secondary steel crash cage around the ramp housing to replace the lost structural integrity of the factory bumper. Additionally, we must analyze the gross vehicle weight distribution. A rear-entry Telluride places the entire combined weight of the heavy stainless steel tub, the folded aluminum ramp, the 400-pound power wheelchair, and the human occupant directly over the rear axle. The factory-independent multi-link rear suspension of a standard Telluride is not mathematically engineered to sustain a permanent, localized payload of 800 pounds directly over the differential. Potential outcomes of ignoring this massive weight redistribution include severe rear-end suspension sag, which dangerously alters the aerodynamic pitch of the vehicle, permanently blinding oncoming traffic by lifting the front headlights directly into their eyes. It also drastically reduces the weight over the front steering tires, compromising your emergency braking distance and your steering responsiveness on wet or icy roads. High-quality conversion facilities mitigate this extreme danger by completely removing the factory rear coil springs and installing heavy-duty, load-bearing air suspension helper springs or vastly stiffer aftermarket coils to re-level the vehicle chassis. If you inspect a rear-entry Telluride on a dealership lot, and the rear bumper is visibly sagging lower than the front bumper while the vehicle is completely empty, walk away immediately, as the vital suspension geometry has been criminally neglected. While the rear-entry Telluride brilliantly solves the infuriating spatial limitations of standard parking lots and offers unparalleled mechanical reliability through its manual ramp system, the forced passenger isolation and the extreme concentration of weight over the rear axle create a highly specific, compromised driving experience that does not suit the independent disabled driver. You are forced to choose between the parking vulnerability of the side entry Traverse and the isolating passenger experience of the rear entry Telluride. But what if there was an apex predator in the mobility market? What if there was a third, highly advanced sport utility vehicle that completely shattered these limitations, offering the absolute best of both worlds? A vehicle that provides front-row driving independence, side entry convenience, and a radical engineering design that completely ignores the traditional dropped floor pan entirely, but utilizes an advanced, automated technology so complex that standard mechanics refuse to even open the hood. This apex predator of the mobility sector is the full-size GMC Yukon, equipped with a highly specialized, aerospace-grade hydraulic lift platform. To comprehend the sheer mechanical genius of this specific architectural approach, you must completely discard everything you have learned about cutting the vehicle chassis in half. Instead of invasively severing the floor pan from the firewall to the rear axle, specialized engineers leave the massive heavy-duty factory floor of the Yukon entirely untouched. The original heavy-gauge steel frame, the complex exhaust routing, the massive high-capacity fuel tank, and most importantly, the factory four-wheel drive transfer case remain exactly where the original automotive designers intended them to be. Because the floor is not dropped by 14 inches, the vehicle retains its original aggressive factory ground clearance. The transformation begins with the side doors. Engineers permanently fuse the front and rear passenger doors together, encasing them in a reinforced steel frame to create a single massive exterior panel. They structurally reinforce the roofline of the Yukon, installing heavy-duty hydraulic hinges and high-torque rotary motors directly into the reinforced roof pillars. When activated via the remote key fob, this enormous fused door panel gracefully swings upward in a dramatic gull-wing motion, completely exposing the entire side of the vehicle cabin, while providing a large, weather-protecting canopy overhead. Simultaneously, an incredibly sophisticated cantilevered steel platform smoothly descends from the original factory floor height, directly down to the pavement. This is not a sloped ramp that you must aggressively drive your power chair up. This is a level, motorized elevator. Imagine a commercial real estate developer named Michael operating in the mountainous regions of Colorado in the year 2026. Michael utilizes a highly complex, heavyweight Group 3 rehabilitative power chair with rugged off-road tires. His daily professional life requires him to constantly navigate heavily rutted, unpaved construction sites, deep snow drifts, and steep gravel inclines to show high-end properties to lucrative clients. If Michael were driving the deeply modified, dropped-floor side-entry Traverse we discussed earlier, the severely compromised 5-inch ground clearance would cause the underside of his vehicle to violently scrape against rocks, potentially rupturing the oil pan or completely tearing off the fragile exhaust system. He would be completely incapable of accessing his own construction sites. However, utilizing the hydraulic lift GMC Yukon, Michael effortlessly drives over harsh terrain because the vehicle mathematically retains its massive 9 inches of factory ground clearance. When he arrives at the site, he deploys the gull-wing door, drives his heavy power chair onto the flat steel platform, locks his brakes, and the hydraulic elevator smoothly lifts him vertically and then slides him laterally, directly behind the steering wheel. He achieves total driving independence, retains unparalleled off-road capability, and arrives with an immense level of executive presence that a traditional lowered minivan could never provide. Historical trends within the highly specialized mobility sector demonstrate that this specific hydraulic configuration profoundly preserves the long-term structural integrity of the base vehicle. Because you are not compromising the central spine of the chassis, the vehicle retains its massive, federally rated towing capacity. You can confidently tow a heavy recreational boat, a large travel trailer, or utility equipment without the paralyzing fear that the custom unibody welds will suddenly snap under the extreme torsional stress of a heavy payload. Furthermore, the external spatial footprint required to deploy this hydraulic platform is drastically smaller than a traditional fold-out ramp. The platform only needs enough lateral space to descend straight down, effectively neutralizing the infuriating parking lot trap where oblivious drivers park too closely to your passenger doors. However, this extraordinary level of mechanical capability introduces a terrifying array of deeply complex, highly expensive vulnerabilities that mobility dealerships will aggressively attempt to minimize during the sales process. The phrase that standard mechanics refuse to even open the hood is not an exaggeration. It is a documented reality. The automated lifting platform relies on a highly pressurized, completely custom hydraulic pump system buried deep within the rear quarter panel of the Yukon. This system requires custom braided steel hydraulic lines, highly specialized fluid reservoirs, and a dense network of proprietary logic boards to coordinate the precise sequence of the gull wing door opening, the platform descending, the safety roll stop flaps engaging, and the internal locking mechanism securing the chair. When this vehicle is driven outside of the immediate geographical radius of the specialized conversion facility, finding a standard automotive technician willing to diagnose a failure is nearly impossible. If the primary hydraulic pump experiences a microscopic seal rupture while you are fully elevated mid-air, or if the logic board suddenly fails due to severe temperature fluctuations, you are physically stranded. While manual emergency backup hand pumps are legally required to be installed, physically operating a heavy hydraulic hand crank to lower a 600-pound payload while trapped in a power chair is virtually impossible for a severely disabled independent driver. Furthermore, you must meticulously analyze the strictly defined payload capacity of the cantilevered lift arm itself. Unlike a heavy-duty drop floor pan that can support well over 1,000 pounds of continuous dynamic weight, these specialized hydraulic platforms typically possess a strict maximum lifting capacity of roughly 600 to 750 pounds. If you calculate the weight of a complex rehabilitative power chair, which frequently exceeds 400 pounds on its own due to massive battery banks and tilt-in space mechanisms, and then add the weight of an adult male occupant, you are instantly operating at the absolute mathematical limit of the hydraulic system. Continually maxing out the payload capacity creates immense, daily physical stress on the cantilever pivot points. Potential outcomes of ignoring these strict weight limitations include catastrophic premature failure of the hydraulic cylinders, the entire platform violently buckling under the heavy dynamic load, or the high-torque roof motors completely burning out while attempting to lift the heavy gull-wing door in high wind conditions. But even with the severe risk of catastrophic hydraulic failure and the strict payload limitations, the GMC Yukon lift conversion brilliantly solves the ground clearance dilemma and provides unprecedented independence for the active, professional wheelchair user. It stands as an engineering marvel of the current era. However, this complex integration of custom aerospace hydraulics into a standard civilian sport utility vehicle raises an entirely new, deeply concerning question about modern automotive electronics. What exactly happens when mobility engineers intercept the incredibly sensitive, factory-installed central nervous system of a $90,000 luxury SUV to artificially command these massive external hydraulic pumps? The forced integration of custom aftermarket logic boards into modern, tightly encrypted factory computer networks has exposed a terrifying, highly prevalent vulnerability in the year 2026, leading to what industry insiders quietly refer to as the phantom battery drain phenomenon. Let us meticulously dissect exactly how this electrical parasite silently kills these luxury sport utility vehicles overnight, leaving drivers stranded in their own garages, and reveal the specific, highly regulated electrical harness you must legally demand in writing before you ever agree to sign the final purchase agreement and take delivery of your incredibly expensive, highly modified machine. To fully grasp the catastrophic potential of the phantom battery drain phenomenon, you must understand the anatomical structure of a modern automotive electrical network in the current year 2026. A luxury sport utility vehicle like the GMC Yukon is no longer a simple mechanical machine. It is a rolling, highly advanced supercomputer. It utilizes a sophisticated communication protocol known as the Controller Area Network, or CAN-bus. This complex digital nervous system connects over 50 distinct microprocessors, governing everything from the fuel injection mapping and the advanced driver assistance systems to the ambient interior lighting and climate control modules. When you turn off the ignition and lock the doors, the vehicle does not simply shut down. It initiates a highly choreographed, sequential sleep cycle, systematically powering down these localized modules over a strictly programmed 30 to 40-minute period to preserve the main engine starting battery. The severe vulnerability occurs when mobility engineers forcefully introduce a custom, aftermarket logic board to control the heavy hydraulic pump, the complex linear actuators, and the massive gull-wing door motors. If this third-party computer brain is poorly integrated or cheaply spliced directly into the factory CAN-bus wiring harness, it creates a disastrous digital miscommunication. The aftermarket mobility board continuously sends unauthorized pinging signals to the factory body control module, essentially tricking the central computer into believing a passenger door is constantly opening or a remote key fob is actively approaching the vehicle perimeter. Because of this relentless digital chatter, the heavy sport utility vehicle never actually enters its vital deep sleep mode. Let us examine a deeply frustrating case study to illustrate the profound real-world consequences of this hidden engineering failure. Imagine if you are Jennifer, a high-stakes corporate attorney operating in the heavily congested urban environment of Chicago in the year 2026. You have just invested over $110,000 into a fully converted, hydraulic lift GMC Yukon specifically to maintain your professional executive image, while accommodating your heavily customized Group 3 rehabilitative power chair. You drive home on a freezing Tuesday evening, park in your climate-controlled garage, turn off the ignition, and assume the massive vehicle is completely powering down. However, the custom hydraulic logic board is aggressively communicating with the factory network all night long. The primary factory battery is being silently and continuously drained by a parasitic draw of roughly 4 to 6 amps per hour. By 6 o'clock the next morning, when you are preparing to leave for an absolutely critical career-defining legal deposition, you press the remote key fob to deploy your heavy gull-wing door and the vital cantilevered lift platform. Absolutely nothing happens. You are entirely trapped outside of your own vehicle. The massive engine battery is completely dead. Furthermore, because the mechanical emergency release levers are located securely inside the completely sealed passenger cabin, you cannot even manually open the hood to attach a standard lithium jump starter pack. You are physically paralyzed by an invisible electrical flaw. You are forced to call a specialized heavy-duty tow truck, but because the vehicle has zero electrical power, the electronic transmission is permanently locked in park, meaning the tow operator must aggressively drag your luxury vehicle out of the garage on specialized skates, potentially causing severe mechanical damage to the complex all-wheel drive transfer case. This terrifying scenario is precisely why you must never authorize a vehicle build without legally demanding a highly specific, strictly regulated electrical harness configuration in writing. You must force the mobility conversion facility to install an entirely independent, fully isolated secondary auxiliary battery system, governed by a sophisticated, unidirectional smart battery isolator relay. This specialized component acts as the ultimate electrical firewall. It mathematically ensures that the massive factory alternator can charge the secondary auxiliary battery while the engine is actively running, but it strictly physically severs the connection the microsecond the ignition is turned off. This vital separation dictates that your heavy mobility equipment, your hydraulic pumps, and your custom logic boards draw their massive power exclusively from the isolated secondary battery, completely protecting your primary engine starting battery from any parasitic drain overnight. Historical trends within the specialized automotive sector reveal a deeply concerning pattern regarding original manufacturer warranties when this specific electrical isolation is ignored. If you tow that completely dead, electrically compromised Yukon into a standard, factory-certified GMC dealership, the master technicians will immediately plug their proprietary diagnostic scanners into the onboard diagnostic port. They will instantly detect the unauthorized aftermarket logic board splicing, the parasitic draw, and the subsequent network communication failures. They will explicitly document in the permanent, global service record that the third-party mobility conversion directly caused the catastrophic electrical drain. This action legally and permanently voids your incredibly valuable factory powertrain and complex electrical warranties. You are immediately caught in a vicious, highly expensive financial crossfire between the massive automotive manufacturer and the Independent Mobility Conversion Facility, with neither corporation accepting the massive financial liability for the required repairs. Furthermore, you must aggressively question the exact physical placement of this absolutely necessary secondary auxiliary battery. In the current automotive landscape of 2026, the engine bays of full-size sport utility vehicles are incredibly dense, packed tight with massive air intakes, complex hybrid cooling reservoirs, and emissions equipment, leaving absolutely zero physical space for a heavy secondary battery under the hood. Therefore, the mobility engineers are forced to custom fabricate a heavy-duty steel battery box and mount it deep within the interior rear cargo area of the vehicle. You must physically verify that this custom interior battery box is strictly vented directly through the vehicle floor pan to the outside atmosphere using industrial-grade tubing. Heavy-duty lead-acid or even high-output absorbed glass mat batteries naturally off-gas highly volatile, explosive hydrogen fumes during the heavy alternator charging cycle. If the mobility dealership installs an unvented auxiliary battery inside the completely sealed passenger cabin of your sport utility vehicle, they are creating a severe, highly dangerous chemical hazard that poses an immense, silent threat to your physical safety and respiratory health over time. Now that we have meticulously exposed the terrifying electrical vulnerabilities, the massive parasitic battery drains, and the extreme structural modifications required for dropped floors and heavy hydraulic lifts, we must pivot our deep dive masterclass to an entirely different, incredibly urgent dimension of accessible sport utility vehicles. What happens when the physical dimensions of the wheelchair user fundamentally clash with the unalterable geometry of the driver's station? There is a highly specific, completely unforgiving mathematical measurement, almost universally ignored by standard salespeople rushing to close a deal, that strictly dictates whether you will be driving comfortably or suffering from severe, permanent spinal compression. It all hinges on the exact, unchangeable placement of the factory steering column, the strict deployment angle of the frontal airbags, and the precise eye-level alignment required for safe highway navigation, which brings us to the shocking reality of the driver position geometry in heavily modified sport utility vehicles. When automotive engineers at major manufacturing plants design the front cabin of a luxury SUV, they utilize incredibly sophisticated ergonomic software to calculate the exact spatial relationship between the adjustable driver seat, the fixed steering column, the instrument cluster, and the strictly regulated airbag deployment zones. This mathematical window is designed to safely accommodate everyone from a small-framed adult to a significantly taller individual. However, the moment you remove that highly adjustable factory-installed seat and attempt to pilot the vehicle directly from a complex rehabilitative power wheelchair, that carefully calculated ergonomic window shatters completely. A standard power wheelchair is a highly rigid, specialized medical apparatus. Due to the massive battery trays, the complex tilt and recline actuator motors situated beneath the seat pan, and the heavy-duty suspension casters, the inherent seat-to-floor height of a modern Group 3 power chair typically rests between 22 and 24 inches off the ground. When you roll this massive piece of medical equipment into the driver's station of a converted sport utility vehicle, you are entirely at the mercy of the structural floor drop. If you purchase an SUV with a standard 10-inch floor drop instead of a highly invasive 14-inch structural cut, the vertical geometry becomes instantly disastrous. Because you are sitting mathematically higher than the original automotive designers intended, your physical eye line is forced directly into the roof header or the dark upper tint band of the windshield. You cannot clearly see overhead traffic lights without severe neck strain, and your visibility of immediate road hazards is heavily compromised. But the lack of visibility is only a minor inconvenience compared to the terrifying safety implications regarding the supplemental restraint systems. Modern steering wheel airbags deploy at speeds exceeding 200 miles per hour. They are meticulously engineered to strike the dense bone structure of the human sternum to rapidly decelerate the upper body during a severe frontal impact. When a wheelchair user sits too high in the driver position, that incredibly violent airbag deployment zone is no longer aimed at the chest. It is aimed directly at the soft tissue of the throat, the mandible, and the cervical spine. Historical trends within independent crash testing facilities show that this exact anatomical misalignment leads to potential outcomes involving catastrophic, life-altering injuries, even in relatively minor, low-speed collisions. Let us examine a highly detailed case study to vividly illustrate this hidden geometrical trap. Imagine if you are a software architect named Robert residing in the rapidly expanding metropolitan area of Austin, Texas, in the current year 2026. Robert sustained a high-level spinal cord injury, and utilizes a customized power chair with a center-mounted, articulating foot platform. He absolutely refuses to drive a lowered-floor minivan and insists on purchasing a heavily modified sport utility vehicle for his daily commute to the technology campus. Robert visits a local uncertified dealership and purchases an SUV that looks structurally sound from the exterior. However, upon his first extended highway commute, the geometrical nightmares begin. The heavy steering column of the sport utility vehicle permanently intrudes deep into the cabin space. Because Robert utilizes a center-mounted foot platform on his power chair, his feet project significantly forward. The metal footplate of his chair violently collides with the lower dashboard fascia, and the rigid steering column housing long before his torso is close enough to safely reach the steering wheel. He physically cannot pull his wheelchair forward into the correct driving position. To compensate for this massive physical barrier, Robert is forced to completely lock his elbows and severely hyperextend his shoulders simply to grip the wheel. Furthermore, because he cannot reach the factory gas and brake pedals, he must utilize mechanical hand controls. But since his chair is positioned so far back due to the footplate interference, the steel linkage rods connecting his hand control apparatus to the floor pedals are stretched to their absolute maximum mechanical limit. This extreme angle creates immense, dangerous friction within the hand control system, requiring Robert to exert massive physical force just to apply the brakes. By the time Robert arrives at his office, his shoulders are in agonizing pain, his reaction times are severely delayed, and he is operating a heavy machine in a highly compromised, physically exhausting posture. This scenario is a massive failure of structural geometry, and it is a trap that hundreds of eager buyers fall into every single year, because they fail to physically test their specific wheelchair inside the driver's station before signing the non-refundable financing documents. Beyond the steering column and the footplate interference, we must deeply analyze the highly complex world of zero-effort steering modifications required for individuals with limited upper body strength. In the year 2026, modern sport utility vehicles do not utilize old-fashioned hydraulic power steering pumps driven by an engine belt. They utilize highly advanced electronic power steering racks governed by sophisticated computer algorithms that adjust the steering resistance based on the current speed of the vehicle. If you require zero-effort steering to safely pilot your SUV, mobility engineers must perform an incredibly invasive, highly controversial surgical procedure on the factory steering column. They must completely remove the factory electronic steering rack, bypass the deeply encrypted anti-lock braking system sensors, and install a custom, highly pressurized hydraulic steering system that dramatically reduces the physical force required to turn the wheel from roughly 40 ounces down to a microscopic 6 ounces of pressure. This extreme modification allows a driver to pilot a massive, heavy sport utility vehicle using only a single finger or a specialized joystick. However, you must fundamentally understand the absolute life or death dependency this creates. If you are driving a factory standard vehicle at 70 miles per hour and the engine suddenly stalls, the standard power steering fails, but the driver can still physically muscle the heavy steering wheel to guide the car to the shoulder. If you are a disabled driver utilizing a zero-effort steering modification and your engine stalls, you mathematically do not possess the upper body strength to turn that heavy wheel manually. The steering wheel becomes locked in place, and you become a highly kinetic, uncontrollable projectile on the interstate. To mitigate this terrifying vulnerability, highly certified mobility dealers are legally required to install a complex emergency backup hydraulic system. This heavy-duty secondary pump constantly monitors the main engine pressure. The microsecond it detects an engine stall, this backup system violently kicks in, drawing massive amperage directly from the secondary auxiliary battery we discussed in the previous section. This backup pump provides you with exactly 15 to 20 seconds of artificial, emergency hydraulic steering pressure. That is a strictly limited, rapidly depleting window of time for you to recognize the engine failure, safely navigate across 3 lanes of high-speed traffic, and bring the heavy vehicle to a complete stop on the shoulder before the backup battery drains and the steering permanently locks. The immense complexity of these customized driver control systems transforms the sport utility vehicle from a standard consumer product into a highly specialized, mission-critical piece of medical transportation equipment. The financial burden of maintaining these complex mechanical backups, the highly pressurized custom fluid lines, and the sensitive electronic linkages is absolutely staggering. Standard automotive mechanics will completely refuse to touch a vehicle equipped with zero-effort steering due to the immense legal liability. You are permanently tethered to the specialized mobility conversion facility for every single minor diagnostic check and system recalibration. And this immense, ongoing financial obligation brings us to the most guarded, highly secretive sector of the accessible sport utility vehicle market. You have finally selected the perfect chassis, verified the precise floor drop dimensions, meticulously calculated your gross vehicle weight payload, and successfully integrated your custom driving controls. You believe the stressful journey is finally over. But the true financial gauntlet has not even begun. What standard mobility sales representatives will aggressively hide from you until the ink on the contract is permanently dry is the catastrophic, industry-wide crisis regarding specialized automotive insurance underwriting, and the horrifying reality of what happens to the secondary market value of your $90,000 custom machine the exact moment you drive it off the commercial lot. An aggressive depreciation cliff so steep that it regularly forces independent disabled drivers into immediate, insurmountable financial ruin. This catastrophic financial reality begins with the fundamental misunderstanding of how massive insurance conglomerates algorithmically evaluate heavily modified mobility vehicles. When you purchase a standard, mass-produced sport utility vehicle off a commercial dealership lot, the insurance underwriter simply inputs the 17-character vehicle identification number into their centralized database. This algorithmic system instantly generates a highly predictable depreciation curve and assigns an actual cash value based strictly on historical trends for that specific factory model. However, when mobility engineers take that exact same vehicle, perform a highly invasive unibody frame cut, drop the steel floor pan 14 inches, and install $40,000 worth of custom aerospace-grade hydraulics and computerized sliding door tracks, the original vehicle identification number does not magically update to reflect this massive financial addition to the central insurance computer network in the year 2026. Your $90,000 highly customized machine still strictly registers as a basic, unmodified $45,000 base model sport utility vehicle. If you simply call your standard neighborhood insurance broker and add this newly purchased mobility vehicle to your existing automotive policy without meticulously declaring the structural modifications, you are driving directly into a massive financial trap. Imagine if you are a high school principal named Thomas living in a bustling suburb of Atlanta, Georgia, in the current year 2026. Thomas utilizes a highly complex motorized wheelchair and just financed a fully converted, side-entry Chevrolet Traverse for $95,000. He secures standard comprehensive and collision coverage, assuming his massive financial investment is fully protected. 6 months later, while sitting at a red light, a distracted driver violently rear-ends his vehicle. The impact completely destroys the heavy-duty electronic kneeling suspension, shatters the custom fiberglass sliding door, and permanently bends the aerospace-grade aluminum in floor ramp housing. The vehicle is structurally compromised and officially declared a total loss by the insurance adjuster. When the claims department processes the payout, they run the standard factory vehicle identification number. They completely ignore the $40,000 worth of destroyed mobility equipment because it was never specifically insured under a specialized mobility equipment rider. The insurance company issues Thomas a settlement check for $42,000, representing only the depreciated actual cash value of the base Chevrolet Traverse. However, Thomas still owes $88,000 to his auto finance lender for the massive, 10-year specialized mobility loan he signed. Because standard automotive gap insurance policies explicitly exclude aftermarket structural modifications and custom hydraulic lifts from their payout algorithms, Thomas is suddenly left owing $46,000 completely out of pocket for a destroyed vehicle he can no longer drive. Potential outcomes of this exact scenario regularly include devastating personal bankruptcy and the permanent loss of independent transportation. To successfully navigate this terrifying underwriting maze, you must radically alter your approach to automotive insurance. You can never accept a standard actual cash value policy for a heavily modified sport utility vehicle. You must systematically seek out highly specialized mobility insurance underwriters who offer a strictly defined agreed value policy or a specific stated value equipment rider. This requires a tedious, highly documented process where you must submit the original, itemized conversion invoice from the certified mobility dealership directly to the specialized underwriter. This dense legal document must explicitly separate the retail cost of the base factory chassis from the exact labor and parts cost of the drop floor, the linear actuators, the reinforced crash cages, and the highly complex hydraulic lift platforms. The underwriter must legally agree, in writing, to ensure the combined total asset value. This level of comprehensive protection demands a significantly higher monthly premium, But historical trends prove it is the only mathematical method to prevent complete financial devastation in the event of a catastrophic highway collision. Beyond the severe insurance vulnerabilities, we must aggressively dissect the horrifying mathematics of the secondary market depreciation cliff. A standard passenger vehicle depreciates the moment you drive it off the lot, but a custom mobility vehicle experiences a violently accelerated depreciation curve that standard dealerships will intentionally conceal from you. This extreme financial bleed is driven by the hyper-specific, highly individualized nature of mobility engineering. When you custom order a sport utility vehicle, you are tailoring the exact ramp angle, the specific interior floor tie-down placements, the exact driver's seat transfer base height, and the deeply integrated zero-effort steering mechanics precisely to your unique anatomical measurements and your specific medical equipment. When you eventually attempt to sell this highly customized vehicle on the secondary market 5 years later, you are not simply looking for a buyer who wants a used sport utility vehicle. You are searching for a microscopic demographic needle in a massive haystack. You must find another disabled driver whose specific power wheelchair perfectly matches your custom tie-down geometry, whose upper body strength aligns with your specific electronic steering modifications, and who possesses the exact physical dimensions to utilize your custom floor drop without suffering severe visibility issues or lethal airbag misalignment. Because this perfectly matched secondary buyer is statistically incredibly rare to find in your immediate geographical area, the actual resale value of your customized machine absolutely plummets. Dealerships aggressively capitalize on this extremely narrow secondary market. If you attempt to trade in your heavily modified sport utility vehicle back to a certified mobility dealer, they will mathematically devastate your trade-in valuation. They know they will have to invest thousands of dollars to meticulously rip out your custom electronic driving controls, unbolt your specific locking mechanisms, and attempt to return the heavily modified driver station to a neutral, universally accessible configuration before they can even attempt to resell it to the general disabled public. Therefore, the $40,000 mobility conversion you financed essentially evaporates in value, sometimes retaining less than 20% of its original retail cost within the first 36 months of ownership. You must factor this catastrophic, unavoidable financial bleed into your long-term household budget before you ever commit to a decade-long mobility loan. You are now armed with the deeply complex engineering structural knowledge, the terrifying electrical integration vulnerabilities, the strict anatomical geometry requirements of the driver station, and the massive financial insurance traps that define the modern accessible sport utility vehicle market. You understand exactly why the heavily modified Traverse, the rear entry Telluride, and the hydraulically equipped Yukon demand such extreme due diligence. But even if you perfectly navigate the engineering inspections, calculate the strict gross vehicle weight ratings, successfully secure an ironclad agreed value insurance policy, and fully accept the brutal mathematics of the secondary depreciation market, there is one final, incredibly secretive barrier standing between you and your driving independence. It is a highly controversial, deeply predatory financial gatekeeper that standard commercial auto dealerships aggressively utilize to legally discriminate against specialized mobility vehicle loans, actively trapping desperate buyers in highly toxic, subprime interest rates unless they clearly understand how to legally leverage a highly specific federal tax loophole regarding legally permissible medical necessity tax deductions, and the highly guarded, notoriously rigid algorithms of specialized adaptive equipment financing. When you walk into a standard commercial bank, or when you log into your local credit union portal in the year 2026 to secure a traditional automotive loan, you are not negotiating with a human being who inherently understands the medical necessity of your situation. You are dealing with entirely uncompromising computer algorithms that govern a strictly enforced, merciless financial metric known throughout the banking industry as the loan-to-value ratio. To fully comprehend the sheer scale of this financial trap, you must mathematically break down the dual nature of an accessible sport utility vehicle purchase. You are essentially buying two completely distinct products that have been forcibly welded together. The base factory chassis, which costs roughly $55,000, and the custom structural mobility conversion, which easily adds an additional $40,000 to the final invoice. When the standard banking algorithm processes your $95,000 loan application, it strictly scans the original 17-character vehicle identification number. The central banking database instantly identifies the collateral solely as a $55,000 factory chassis. It mathematically zeroes out the $40,000 of custom aerospace-grade hydraulics, the dropped steel floor pan, and the electronic driving controls, viewing them not as valuable collateral, but as destructive, value-decreasing aftermarket modifications. Therefore, when you request a $95,000 loan for an asset the computer strictly values at $55,000, your loan-to-value ratio violently spikes to an unapproachable 172%. Standard automotive underwriters absolutely will not finance a standard automotive asset past a 120% loan-to-value ratio. When the algorithm detects this massive discrepancy, it immediately flags your application. It does not necessarily reject you. Instead, it executes a far more predatory maneuver. It completely removes your application from the highly regulated, low-interest prime automotive lending tier and forces you into the deeply toxic, highly unregulated tier of unsecured subprime personal loans. Let us examine a highly detailed, numerically accurate case study to illustrate the catastrophic potential outcomes of falling into this exact financial trap. Imagine a dedicated public school administrator named Emily, living in the rapidly expanding suburbs of Phoenix, Arizona, in the current year 2026. Emily utilizes a heavy pediatric power chair for her son and desperately needs the structural space of a side-entry modified Chevrolet Traverse. She visits a standard commercial auto dealership that occasionally brokers modified vehicles. The finance manager, either through sheer ignorance of specialized underwriting or a predatory desire to maximize his back-end commission points, submits her $95,000 application to a standard commercial banking network. Because of the violently skewed loan-to-value ratio, the bank approves the loan, but assigns a predatory 14% annual percentage rate over a massive 120-month term, treating the excess $40,000 essentially as a massive credit card debt. Over the 10-year life of that specific loan, Emily will mathematically pay roughly $80,000 purely in compounding interest charges, effectively doubling the true cost of the vehicle and completely destroying her long-term household financial stability. To legally and safely bypass this predatory gatekeeping, you must completely abandon standard commercial automotive lenders and exclusively seek out highly specialized mobility equipment finance institutions. These boutique lenders operate on a fundamentally different, completely specialized underwriting algorithm. They inherently understand that the $40,000 mobility conversion is not a destructive aftermarket accessory, but a highly valuable, tangible piece of medical equipment that serves as secure collateral. However, to trigger this specialized prime lending algorithm, you must aggressively demand a highly specific, legally binding documentation structure from your mobility dealership before you ever submit a credit application. You must force the dealership to generate a split invoice, formerly known as a dual contract bill of sale. This hyper-specific legal document mathematically and legally separates the exact manufacturer-suggested retail price of the base sport utility vehicle from the exact itemized labor and parts cost of the structural mobility conversion. This split invoice is the ultimate skeleton key to financial survival in the mobility market, and it directly ties into the highly complex, massively beneficial federal tax loophole regarding medical capital expenses. We must explicitly state that this is for educational purposes and you must consult a certified public accountant, but historical trends regarding the United States Internal Revenue Service Tax Code, specifically Publication 502 concerning medical and dental expenses, reveal a profound financial mechanism for disabled drivers. The tax code traditionally allows taxpayers who itemize their deductions to include the specific costs of special hand controls and other special equipment installed in a motor vehicle for the use of a person with a disability. Furthermore, the historical interpretation of this specific tax law dictates that the amount by which the cost of a car specially designed to hold a wheelchair is more than the cost of a regular car is considered a deductible medical expense. When you possess that legally binding split invoice, your certified public accountant can clearly present the exact itemized cost of the $40,000 dropped floor, the linear actuators, and the structural engineering directly to the federal government as a legitimate, necessary medical capital expense. For independent disabled drivers or families with massive medical overhead, legally leveraging this specific tax deduction can drastically reduce their annual adjusted gross income, potentially resulting in a massive tax return that can be immediately applied to the principal balance of the specialized mobility loan, effectively neutralizing the brutal early depreciation curve of the vehicle. If you simply accept a standard single-line item invoice from a careless dealership, you completely destroy the paper trail required by the federal government, permanently forfeiting tens of thousands of dollars in legitimate, legally permissible tax relief. However, even when you perfectly navigate the specialized underwriting algorithms, successfully secure a prime interest rate through a boutique mobility lender, and brilliantly execute the split invoice strategy to maximize your federal medical deductions, you are entirely legally bound to a highly complex, heavily modified machine for the next 7 to 10 years. You have the vehicle, you have the specialized agreed value insurance, and you have the optimal financing. You finally drive your incredible $90,000 accessible sport utility vehicle into your daily routine. But exactly 5,000 miles later, you encounter a completely mundane, unavoidable mechanical necessity that hides a terrifying, physically destructive threat. It is a threat so common and so heavily overlooked that it structurally destroys hundreds of highly expensive mobility vehicles every single year across the United States. What happens when you drive your heavily modified, dropped-floor sport utility vehicle into a standard rapid service oil change facility or a neighborhood tire rotation shop? The devastating reality of the factory chassis lifting points, the catastrophic failure of standard commercial automotive hydraulic hoists, and the irreversible unibody frame damage that standard mechanics will aggressively try to hide from you immediately brings us to the terrifying operational reality of routine maintenance on a highly customized mobility vehicle. When an automotive engineer at General Motors or Kia designs a factory chassis, they strictly calculate the gross vehicle weight and establish 4 highly reinforced structural nodes along the lower rocker panels, universally known as pinch welds. These 4 microscopic points are mathematically engineered to sustain the entire weight of the vehicle when it is hoisted into the air on a standard 2-post commercial lift. However, when you purchase a deeply modified side-entry Chevrolet Traverse, the mobility engineers completely sever these vital factory pinch welds along with the original floor pan. To accommodate the massive 14-inch floor drop, they fabricate an entirely new, heavily customized lower subframe. To hide this invasive structural surgery and maintain the premium aesthetic of the sport utility vehicle, they install fragile, custom-painted fiberglass ground effects completely covering the lower rocker panels. The new structurally sound lifting points are completely hidden deep underneath the vehicle, often requiring specialized, extended lift pad adapters to safely reach. When you drive your $95,000 machine into a rapid service oil change franchise, the technicians are trained on extreme volume and speed. They do not consult custom mobility manuals. They rapidly kick the standard steel lift arms under the edge of your vehicle and engage the high-pressure hydraulic hoist. Because the custom fiberglass side skirts sit significantly lower than the factory frame, the steel lift arms instantly violently crush the fragile fiberglass before they ever make contact with the structural steel. This immediate impact shatters the specialized aesthetic panels, which cost thousands of dollars to custom fabricate and paint. But the cosmetic destruction is merely a superficial warning sign of a much deeper, catastrophic mechanical failure. If the technician continues to hoist the vehicle using these incorrect, structurally compromised contact points, the immense pressure of the lift arms will violently punch directly through the thin outer sheet metal and aggressively crush the complex, highly sensitive wiring harnesses and the heavy-duty electronic linear actuators that govern your kneeling suspension system. You have instantly sustained tens of thousands of dollars in irreversible unibody and electrical damage before the oil has even been drained. Let us analyze a highly detailed case study to vividly demonstrate the extreme financial liability of this operational oversight. Imagine if you are Robert, a retired mechanical engineer living in a rapidly developing suburb of Dallas, Texas, in the current year 2026. Robert rigorously follows the maintenance schedule for his heavily modified, dropped-floor sport utility vehicle. He takes it to a highly rated neighborhood tire rotation facility. The technicians place the vehicle on a standard symmetrical 2-post lift. This is where the violently altered center of gravity creates a lethal physical threat. A factory sport utility vehicle is meticulously balanced. A side-entry mobility vehicle is mathematically severely imbalanced. You have an 800-pound aerospace-grade aluminum ramp housing, heavy-duty sliding door tracks, and a massive linear kneeling actuator entirely concentrated on the right passenger side of the chassis. When the symmetrical lift elevates Robert's vehicle 6 feet into the air, the massive lateral weight discrepancy violently shifts the center of gravity. As the technician begins to apply heavy torque to remove a lug nut on the left side, the vehicle structurally destabilizes. The heavily weighted passenger side violently pulls the chassis off the standard lifting pads. Potential outcomes of this exact, historically documented scenario include the entire $95,000 vehicle catastrophically crashing down onto the concrete service bay floor, utterly destroying the complex mobility conversion, permanently twisting the custom subframe, and potentially causing lethal injuries to the service technicians. When Robert attempts to file a claim, his specialized agreed value insurance immediately denies the payout because the destruction was caused by third-party gross negligence. The commercial liability insurance of the tire facility aggressively fights the claim, legally arguing that the vehicle was abnormally constructed and inherently dangerous to service. Robert is trapped in a devastating multi-year legal nightmare, completely without his independent transportation, simply because of a routine tire rotation. To absolutely guarantee your financial and physical safety, you must radically alter your approach to standard automotive maintenance. You must treat your heavily modified sport utility vehicle strictly as a specialized piece of commercial heavy machinery. You must permanently keep the highly detailed, mathematically precise conversion schematic provided by the mobility manufacturer inside your glove compartment at all times. You cannot simply hand over your keys and wait in the customer lobby. You must physically demand that the service manager accompanies you into the active service bay. You must utilize the schematic to visually verify and physically point out the exact, custom reinforced subframe lifting nodes to the technician before the hoist is ever engaged. Furthermore, historical trends within the mobility sector absolutely dictate that you should aggressively refuse service from any facility that utilizes a standard two-post frame lift. You must strictly mandate that your custom vehicle is exclusively serviced on a heavy-duty, for post-drive on alignment rack. This specialized equipment allows you to drive the entire vehicle onto two massive steel runways, perfectly distributing the imbalanced weight across the tires just as it rests on the highway, completely eliminating the terrifying threat of the vehicle violently slipping off localized lifting pads and utterly bypassing the fragile fiberglass ground effects. This strict operational protocol applies equally to the rear entry Kia Telluride and the hydraulic lift GMC Yukon. With the rear entry Telluride, the immense weight of the stainless steel tub and the rear ramp permanently shifts the center of gravity heavily toward the rear differential. If a technician incorrectly positions the lift arms too far forward, the vehicle can violently tip backward the moment the heavy engine oil is drained from the front block. With the highly advanced GMC Yukon, the threat is entirely hidden beneath the massive factory floor. The specialized aerospace-grade hydraulic pump that powers your vital lift platform relies on a complex network of high-pressure braided steel lines routed directly along the factory frame rails. If a careless mechanic places a heavy steel lift pad directly over one of these sensitive hydraulic lines and hoists the heavy vehicle, the immense pressure will instantly crush the braided steel and microscopically rupture the inner Teflon seal. The technician will lower the vehicle, complete the standard service, and you will drive away completely unaware of the invisible destruction. Hours later, when you attempt to deploy your hydraulic lift platform in a remote parking lot, the highly pressurized hydraulic fluid will violently burst through the compromised line, permanently paralyzing your lifting mechanism and leaving you entirely stranded outside of your vehicle. Navigating the incredibly complex engineering modifications, strictly calculating the driver station geometry, successfully defeating the algorithmic financial traps of commercial underwriting, and rigorously policing the physical maintenance of your machine are absolute necessities for daily survival in the accessible sport utility vehicle market. You have achieved total independence. You are driving the most capable, structurally sound vehicle possible. But the ultimate test of this massive financial and mechanical commitment does not happen in a dealership showroom or a service bay. It happens in the dead of night, in a terrifying high-stress scenario where every single computerized system in your highly advanced machine violently fails simultaneously. What happens when your heavily modified sport utility vehicle experiences a catastrophic total electrical blackout on a desolate interstate, permanently trapping you inside the completely sealed cabin, and the standard emergency manual override protocols require an impossible level of physical strength that standard sales representatives swore you would never need to use. Because the absolute most terrifying vulnerability of any heavily modified, wheelchair-accessible sport utility vehicle is the total loss of catastrophic electrical power while you are physically occupying the driving station. When the complex digital nervous system of the vehicle fails, the highly advanced features that provide your independence instantly transform into impenetrable barriers. Let us examine a deeply intense, highly detailed case study to illustrate the profound physical reality of this extreme scenario. Imagine a dedicated architectural consultant named Samuel, operating in the rural, freezing expanses of northern Michigan in the current year 2026. Samuel drives the highly acclaimed, side-entry modified Chevrolet Traverse. He is returning home from a remote site inspection late at night, when the primary factory alternator catastrophically fails. Because the deeply integrated mobility electrical system heavily relies on this single power generation source, the isolated auxiliary battery is violently drained within minutes, attempting to keep the complex environmental controls and the high-draw electronic steering active. At 60 miles per hour on a desolate, unlit highway, the vehicle suffers a total immediate electrical blackout. The engine instantly dies, the zero-effort electronic steering violently locks into place, and the heavy sport utility vehicle coasts to a stop on the frozen shoulder. The interior cabin goes pitch black. Samuel is completely uninjured, but the external temperature is rapidly dropping below freezing. He presses the emergency deployment button on his remote key fob to open the custom sliding door and lower the in-floor ramp so he can evacuate the freezing vehicle. Absolutely nothing happens. The massive, high-torque electric motors that control the door and the linear kneeling actuators are completely dead. Standard dealership sales representatives frequently assure eager buyers that every single mobility vehicle is legally required to possess a manual emergency override system. However, they intentionally gloss over the horrifying physical physics required to actually operate these secondary systems. To manually open the custom side entry door on a modified Traverse, the disabled driver must reach down to the deeply recessed floor pan, locate a specific mechanical steel release lever, and pull it with immense force to disengage the heavy internal locking teeth from the door track. Once the lock is mechanically bypassed, the driver must then physically push the massive, custom fabricated fiberglass sliding door open. This door has been heavily reinforced with thick steel crash beams to meet federal side impact safety standards, meaning it weighs well over 200 pounds. Pushing 200 pounds of dead weight backward against the extreme friction of an unpowered mechanical track, while sitting at an awkward angle inside a rigid power wheelchair, requires a massive level of upper body core strength that the vast majority of specialized mobility drivers mathematically do not possess. Even if Samuel miraculously manages to violently force the heavy door open, he is now faced with the secondary mechanical nightmare of the manual ramp override. The heavy aerospace-grade aluminum and floor ramp must be manually extracted using a secondary T-handle strap. He must lean completely out of the vehicle cabin, grab the strap, and forcefully pull the heavy metal ramp out of its deeply recessed housing. But because the electronic kneeling suspension is completely dead, the vehicle remains at its absolute highest factory ground clearance. When the ramp finally deploys, it slams onto the pavement at an impossibly steep, incredibly dangerous angle. If Samuel attempts to drive his heavy Group 3 power chair down this severely unlevel, non-compliant slope in the freezing dark, the potential outcomes include the heavy chair violently tipping forward, launching him out of the vehicle and directly onto the frozen highway. This terrifying mechanical reality is equally catastrophic across the other structural platforms. If you are trapped inside the rear entry Kia Telluride and the electrical system completely fails, you cannot physically reach the rear lift gate from the passenger position. Even if you could, the heavy rear hatch requires massive physical force to push upward against the dead hydraulic factory struts. In the highly advanced hydraulic lift GMC Yukon, the manual override system consists of a heavy-duty hydraulic hand pump explicitly designed to lower the massive cantilevered floor platform in an emergency. However, this manual pump is securely bolted into the rear cargo quarter panel, utterly and completely inaccessible to the disabled driver, who is rigidly locked into the front steering station. You are entirely dependent on a completely random passerby or an emergency first responder knowing exactly how to locate the hidden access panels, decipher the complex mobility override schematic, and operate the heavy hydraulic hand pump from the outside of the vehicle. To permanently neutralize this lethal threat, you must execute a rigorous, non-negotiable physical test before you ever agree to finance a custom mobility vehicle. You must demand that the dealership completely disconnects the main engine battery and the secondary auxiliary battery while you are sitting in the driver's seat inside their climate-controlled showroom. You must personally attempt to manually operate the specific emergency egress protocols completely unassisted. If you cannot physically pull the high-tension steel cables, if you cannot manually push the 200-pound reinforced door, or if you cannot safely navigate the steep unkneeled ramp angle, that specific vehicle architecture is a severe, life-threatening trap that you must aggressively walk away from. Furthermore, historical trends in extreme weather survival dictate that disabled drivers must never rely solely on the factory automotive communication network. You must permanently install a completely independent, battery-operated satellite communication device physically mounted directly to your power wheelchair, guaranteeing that you can immediately dispatch emergency medical services directly to your exact global positioning coordinates, even if the sport utility vehicle is a completely dead, locked steel vault. This deep dive masterclass has meticulously deconstructed the absolute zenith of the accessible automotive market in the United States. You now completely understand the extreme, highly invasive unibody frame destruction required to create the side-entry Chevrolet Traverse, and you know exactly how to mathematically calculate the remaining payload capacity to prevent catastrophic suspension collapse. You comprehend the profound spatial independence of the rear-entry Kia Telluride, while fully recognizing the severe psychological passenger isolation and the dangerous rear axle weight distribution it demands. You have analyzed the absolute mechanical genius of the hydraulic lift GMC Yukon, unlocking unprecedented off-road capabilities and executive ground clearance, while acknowledging the terrifying vulnerability of completely custom logic boards, phantom parasitic battery drains, and highly specialized maintenance requirements. You have mastered the deeply hidden financial algorithms of loan-to-value ratios, predatory subprime lending traps, and the absolute legal necessity of the dual contract split invoice to maximize your federal medical tax deductions and survive the brutal, inevitable secondary market depreciation cliff. You possess a level of structural, electrical, and financial intelligence that fundamentally supersedes the standard commercial sales process. You are no longer a vulnerable consumer walking blindly into a highly predatory, medically necessary transaction. You are an aggressively informed, analytically driven buyer who demands strictly regulated electrical isolation harnesses, verified secondary structural crash data, and independently confirmed driver positioning geometry to protect your physical safety and your financial legacy. The choice between the side entry, the rear entry, and the advanced hydraulic lift platform ultimately depends entirely on your highly specific daily environment, your strict parking realities, and your individual upper body physical mechanics. But this masterclass on accessible sport utility vehicles is only one fraction of the massive, highly complex mobility industry. Because while sport utility vehicles dominate the suburban landscape, there is an entirely different, incredibly aggressive segment of American drivers who absolutely demand the raw payload capacity, the massive towing power, and the open cargo utility of a full-size, heavy-duty pickup truck. And what standard dealerships will intentionally hide from you is that cutting the frame of a half-ton pickup truck initiates a deeply terrifying, structurally violent phenomenon known throughout the engineering world as catastrophic chassis twist, a flaw so destructive it routinely snaps factory driveshafts in half while driving at highway speeds, which leads us directly into the horrifying engineering reality of our next exhaustive breakdown.